Okay, what did we do last time? We started by just talking about what is math, because it's more than just what math textbooks look like. The Factfulness book you started reading was sort of to emphasize that there's a lot of math in the world that looks nothing like a traditional math textbook. And there's numbers, there's formulas, there's computations, there's talking about things, and so on. Then we talked about where you get formulas. Formulas come from patterns, and some patterns we can observe ourselves and make the formulas out of them. And we did examples of this kind of thing here, there. Then there were formulas that were too complicated for us to actually design ourselves, like some of the ones for metabolism that we'll see later. So some formulas we'll just have to trust someone else observed the patterns, and others we'll get to observe the patterns ourselves. We didn't get to do this cute thing, so let's do that now. I can make this a little bigger. Our in-class activity of why clouds float but rain falls. So, anyone know before we look at this diagram? Weight. It's certainly about weight. And it's about pressure.
Condensing, it gets heavier in one spot and falls.
Yes. So imagine that you're one of those little water strider bugs walking on some water. Why don't you fall through? You have gravity pulling you down, but there's surface tension that's keeping you up. So similarly, when you have air, it's not that the air has surface tension, but there's some friction of pushing through the air. You would feel it if you stick your head out of the car like a dog. So if you have a tiny, tiny, tiny speck of water, then you have a certain amount of weight, like how many orange squares are there, and you have a certain amount of how much of the bottom is pushing against all of the air molecules. So you're sort of resting on air to a tiny bit. So there's a pattern of the weight, and there's a pattern of how much is the blue highlight that might be hard to see on the screen. As the water condenses and gets bigger, each drop gets bigger, the patterns don't increase at the same rate. The weight goes up like the square pattern. We saw the square pattern on Tuesday. It's going to go 1, 4, 9, 16, 25, and so on. It gets bigger pretty fast. The air resistance, it's not a squared, it's just a multiply by n pattern. We saw a bunch of those on Tuesday also. So 2, 4, 6, 8, like each step down it gets bigger. Now this diagram is too simple, because really we have a three-dimensional thing, not a very flat thing. So in real life, it's actually a cubic and a squared, but we're going to ignore that, because the point remains that the weight pattern just gets bigger a lot faster than the resistance pattern, the surface area pattern. And I don't know how much bigger it has to be. Maybe the weight has to be 100 times bigger, or 1,000, or 10,000, or who knows what number it is, to push through the air resistance and actually make the raindrop big enough to fall. But whatever that factor is, it will get that big, because that pattern gets bigger so much faster than the surface area one. I'll say that again in a different way. Maybe the weight pattern has to be 50 times as much, or 100 times as much, or something. It will eventually get there. Okay, I'm not going to have you do this because you're not on a roll at the end of the first class anymore. This will be our warm-up instead, but there we go. Okay, onward. We talked about the triangle formula. You can read that on your own. Time management is the first study skill we'll talk about. Let's do that briefly. This is mostly something you can read at home. There's things to do before the term begins. It's a little late now, since we're towards the end of the first week, but in general, don't treat a college class like a drag race, where you show up to the room and have to run off at a quick start right away. Right? Have some momentum before you actually show up in class for the first time, and things will be a lot easier. So we talk about that a lot, and the one I want to emphasize, because it's sort of my job to scare you a little bit, but only a little realistically, is to think about your support network. Because none of the math we do, as I said Tuesday, is really hard. It might seem hard when it's new, because new things can be hard just because they're new. But once you get into it, nothing we do in math is hard. The people that fail this class don't fail it because of the math we do. They fail it because their car breaks down, or their kid gets sick, or their mother goes into intensive care, or they have to change a job, or something like that. That's the real life issues that kind of broadside people, and then we don't see them anymore. So if you're now Thursday of week 1 and you haven't done anything for your support network, then check in with that. I can tell you a story of a student in Math 20 many terms ago who was the most drama magnet person I ever knew, managed to pull off a C in the class and pass despite having so many terrible things happening. And some things that weren't terrible, but terribly distracting. And I have other students that are successful in different ways. One Math 20 student was just scraping by, like C- level work. And then week 7, she suddenly turned into an A student. So I said, I don't know what you are doing differently now that it's week 6 or 7, but congratulations, whatever you're doing is working. And she said, oh, well, I was living in my car, but now I'm couch surfing at my friend's house, and it's a lot easier to do homework at your friend's couch than in the car. So those are the encouraging stories that, yes, we all have real life things going on, and we can manage anyway. But I've also had students that come to me, and they've been working hard all term, except I've only seen them about half the classes. They're learning what they can. They know they're going to have to repeat the class because they didn't have enough hours this term to deal with it. And I had one fellow who, as he was turning in the final, which we both knew he was failing, but he wanted to see what he had learned because it would help him study for next time, said, I guess I shouldn't have taken this math class the same term I was starting a new business and going through a divorce. And I said, yeah, that seems like a bit much for 10 weeks. So I have no idea how he's doing now. But if you are that person, if this is just the wrong 10 weeks for you to be here, then I can see you later on. It doesn't have to be this term. But hopefully no one has quite so much going on that you know about already. And fall is usually a good term. There's not as many car accidents and people getting sick and so on as when the weather gets bad. Okay, there's my scary warning. And the other part of the warning is, if you need help with a study group, let me know. It is almost true that the thing that best predicts who will pass Math 20 or Math 25 is who is in a study group. And meeting in person is great. That's sort of the best way to do this work. But if you can't, then just make it like, you want to go running in the morning, it's easier if there's someone else that you're showing up with, because then if you flake out, you'd be letting them down. Right? Do the same kind of thing. Say, I'm going to be doing math homework Thursdays at 6 p.m. by my phone. I want you to be there by the phone, and then if we're stuck, we'll call each other. That will be better than nothing if that's the best you can arrange with your jobs and kids and work and things. Okay, onward for time management. The estimate officially from LCC is if you are in a 3-credit class, it should take you about 9 hours a week. 3 for being there and 6 more for homework. So take your credits total, multiply by 3, add how much you're at work, and that's like how much work in school is going to suck up your life. So if that number is really big, then maybe do something. That you can read on your own, that you can read on your own. We have an infinite number of practice tests for both this class and Math 20. And if we didn't have a cool thing about why clouds float and rain falls to do as a warm-up, then I could just say, look, here's the Math 20 test. Let's do some of these. So we'll start some classes just doing review. But the review that we need for our Math 25 work is built into the lectures. So this is just sort of extra, keep your brain from forgetting things. Okay, during the term. I told you a moment ago that being in a study group is almost what best predicts who will pass the class. So this is what actually best predicts who will pass the class. It's just harder to measure and count and notice. It doesn't matter how long it's been since you've done math. It doesn't matter what you got as a grade in your last math class. When you start any class, then I have this big personality. Right? Part of my job is to sort of communicate energy and enthusiasm so that you will pay attention and want to do the homework and things like that. It will seem like I'm the main character dancing up here in the front of the room, and you're just doing whatever hoops and assignments and things I make you do. That's sort of unavoidable at the very beginning of any class, math or otherwise. But sometime during the term, that has to change. And it will become, this is your math class. You are the main character in your story of you learning this math. And I am just some other resource that's helping you, like the websites and practice tests and things like that. And once that happens, then you are pretty much safe. Those people always pass the class. Again, unless their kids get terribly sick or something like that. So that's the thing to be going for, when it is that this is your story and I am just a helper for you. So you can't really force it to happen, but enjoy it when it does. And some stuff on test preparation. Okay, good enough. Any questions or issues about time management from what I said or in general? Not too big a deal. In Math 20, this is a big problem because lots of people in Math 20 come right from high school where they could skate by without doing any work, and then they get really surprised. College is different. But if you've gotten to 25 already, then it's pretty much, yeah, you know college is more work. So. Okay, next topic, calories. I won't read the David Berry quotation out loud. Calories measure energy. Our metabolism needs energy even when we're just sitting still. But we need more when we exercise. So our simplest formula is just how many calories do you burn while exercising? It doesn't necessarily have to be simple, by the way. It's sort of astounding that it's not based on your age or your height or what you've eaten recently or who knows what else this pattern could be a pattern about. But for a good estimate, all you need is your weight times how long you exercise times the scale factor. These scale factors on the box on the side are a bunch of baloney, by the way. That if I go and bicycle casually downtown just for fun because it's sunny, and you go and bicycle up over 29th to get to LCC, then that's not the same kind of bicycling at all. Huge hill versus tootling around. So there's actually, who knows how many numbers, right? You can look up other lists online, the more accurate exercise scale factors. But we don't care. This is a math class. We're just learning how to do this. So if I say someone is swimming, this is the number we use. If I say someone is biking, we look it up on the table.
So what does that say? Weight
times minutes times scale factor. If the blue is too dark, I can always change that a little bit too. Okay, so let's do one. Arthur weighs 150 pounds. Is this going to let me highlight? No. Okay, then I have to do that. He runs for an hour and then does half an hour of weightlifting. How many calories does he burn? What do we need to do?
What is the scale factor?
What is it? Yeah, we have to go back. So running is, whoops, I don't want that. I wanted to go this way. So running is 0.09, and then weightlifting is 0.039. So let's put that on our thing. 0.09. Okay, I've written those numbers somewhere on the page. What next?
Convert the hour and the half hour to minutes.
Okay, so that's 60 minutes. And that's 30 minutes.
And what I like to do is set up the formula on the page so I can look at it. So I do weight times minutes times factor.
Okay,
And then
calorie.
plug it in.
It used to be when I wiggled, then the thing would get bigger, but it's not letting my dots get bigger. So if you can't read the dots, let me know and I will try and figure out how to fix that. But if it's not really a problem, I'm not going to worry about it.
And underneath them, I just plug them in. So I
Okay.
can keep it simple.
We have two different things. Yeah. So we're on a roll, but I'm not quite sure which scale factor to plug in. So we actually need to be doing this twice. We have part A and the part B. Does it matter which is part A and which is part B?
No.
Because we only did 30 minutes for the weightlifting and 60 minutes for the running. So
Yeah, we have to keep things straight. It doesn't matter which exercise we assign A or B. We're going to add them up at the end anyway. But we have to be a little paying attention to which goes where. So I'm just going to label it for myself. This will be the running, and this will be the weights. Okay, so he weighs 150. He runs for an hour, and the running factor is 0.09. So 150 times 60 times 0.09, 810.
we're allowed to use our calculator.
Yes, you always can use your calculator. Move that down a little. Whoops. No, I guess I don't. Okay. So he's still 150. Now it's 30 minutes. And it's 0.039. That's about
175.
yeah, so I'll round up. 810, 176. And I'll finally put a box around it.
Do you want us to round up?
I want you to round sensibly. Good segue. I was just about to talk about it. So, do we think he actually burned exactly 986 calories? No. The scale factors themselves were suspiciously accurate. And he's certainly not running exactly the same way in the entire hour, and so on and so forth. So if you wanted to just call this 986, that's fine. That's what the number said. If you wanted to say 990 or even 1,000, round it to the tens or the hundreds, I'd have a hard time arguing that you're wrong. So whatever makes sense to you. I'm just going to do this because then the people who are staying with the most accuracy the numbers gave us can know that they're right. But if you think this is like exaggerating how much the math knows, then yes, this is exaggerating how much we actually know. Okay, let's talk about other things. On this problem, I put a few words in. MIN for minutes by my blue numbers up there. The scale factors, I could have put calories per pound per minute and labeled them, but that was a lot of writing. I skipped that. I could have put words here for pounds and minutes and so on, but I didn't. So I'm being a little sloppy. And I am doing that for two reasons. One, because that's how most of you will write things. And two, because if I really wanted to do it with lots of writing, there's a whole procedure that I'm going to show you now that you don't need to do, but to be well-educated math students who should be aware of this. It's something you should have learned in Math 20 if you came out of Math 20, and it's called a unit analysis. So let me show you that. I'm going to highlight this part. Okay. And I'm going to get rid of that. Okay. So this is formula. For unit analysis, you're going to treat the words, the labels on the numbers, as if they were numerator and denominator fraction things that you could cancel. If I had a fraction that was 14/9 times 6/7, I could say, oh, I'm going to cancel the 7s. Oh, I'm going to cancel the 3s. And multiply across them, right? Canceling is something you've seen before. I'm not going to review fraction arithmetic right now for its own sake. I can actually do the same thing with words. And it might seem strange, because words aren't numbers, but if there's the same word on the top and the bottom, then I can cancel them out.
So what you analysis is basically like medical math? Like
It's used all the time in all kinds of different places. It's a good thing to know. But most people prefer using formulas because you just plug it in and the calculator does all the work.
So would you use that for like, I don't know, like converting a different unit to a different?
Yeah. The famous Math 20 example is I measure a snail traveling in feet per second. How can I make that miles per hour? But the general process you can use all the time in all sorts of things. So I'm not going to ask you to use it. I'm just showing it to you now so it can kind of sit in the back of your brain. And we'll see it later in the term. So how unit analysis works is you take a number and write it down. In this case, we're starting with the 0.09 calories per 1 minute and 1 pound. We know we're running. That's sort of the running fraction. Right? Then I say, okay, what I want is my calories. I don't want the minutes and pounds. I want to get rid of them. So how would I do that? I would multiply by something that has pounds in the top, so that will cancel. In this case, Arthur weighed 150 pounds. If it makes you happy, you can put it over 1. Any plain number you can put over 1 and it doesn't change it. Okay, I've gotten rid of the pounds. I also want to get rid of the minutes. So he runs for 60 minutes. Now all I have left is calories, and they're on top. Right? The units on top are sort of the real things, not the comparison rates. How do I deal with 3 fractions multiplied together? I multiply across the top. I multiply across the bottom. That's just a bunch of 1. And I get whatever that answer was, 810. Everyone knows the squiggly equals means this is the step I rounded in. Put that back here too so it matches. Okay. That's a terrible A. Okay. So you get, that didn't work. The same number, it's just a different style. Here we're not plugging it in a formula. Instead, we're thinking, I have a fraction. There's words I don't want. I want them to cancel and go away. I'm going to use fraction multiplying to make it happen. So just sort of hide it in the back of your brain, put it in the back burner. You will see cases later this term where we don't have a formula. When you have a formula, that's usually simpler. Just plug it in. Everything's happy. And I could kind of do them both. If I went back to this page and tried to squeeze in pounds, minutes, and calories per pound per minute, then I could cancel my pounds and cancel my minutes and sort of have both going on at once. If you've done this a bunch, you'll actually do the pink thinking in your brain, even if you're not bothering to write it out with your pencil.
So do you care if we write down the units in
No.
like our work?
When you have a final answer in a box, it needs its units. Okay? It is a word problem. Ever since little kids, we have to label our word problem answers. But in between, it's up to you. The way I've been trained as a math person, I'm either going to do a good job, make the formula and the unit analysis happen at the same time, or I'm going to be really sloppy, because why be in between? When you're exposed to a new formula, do this sort of thing. Double check that the units actually work. Everything cancels out the way it should. Okay, more just talking, since this is one of our first write them on the board problems of the term. Here's a weird decimal, right? That decimal has several names. When I'm lecturing here at the front of the room, I'm going to say 0.039. And that's just because it helps your ear. By saying 0 point, it's giving your ear a split second more of, oh, decimal coming. If you were sitting next to me in office hours, I would probably just say 0.039, because I'm lazy, just like you are. If we were in a court of law and you were someone that was taking down what everyone was saying, then we would say 39 thousandths. That's sort of its formal name when it gets dressed up for a party. So when you are writing your decimals, you don't have to put the 0 in front. You don't have to say them out loud with the 0 in front. But I'm going to do that because I am lecturing, and that helps you as the audience see everything. Okay, more to talk about. When I write things, later on we'll talk about how to write problems. But my equal signs line up. To some extent, everything else lines up. So I'm trying to model good arranging it on the page. Okay, good enough. Next problem. I have 3 of these. No, only 2. Okay. So your turn. Can I get the chart? Oops, I would have to do it this way. So by yourself with a neighbor.
Oh, okay.
How many parts does this problem have? I hear 3 and I hear 2. You can both be right.
I think like 9 or something. That's the way I consider it.
I'm just asking about like the part A, part B
Oh, okay.
we did. How many different times do we have to use the formula? No, now it's too big. Okay. What do I do for the bicycling?
110 pounds
Mm-hmm.
times 10 minutes times 0.045
Okay.
is 495 calories.
Okay. I could put a 10 there, like you said, and do exactly what you wanted.
Oh,
But then I have to come back and do bicycling again.
right.
So there's nothing wrong with it, but I am more lazy than that. So I'm just going to bundle together all of her bicycling
30 minutes.
and say that there's 10, I should use a different color. There's 10 and 20, and there's 30 minutes here. I might not normally write the unit analysis, but since I just talked about it, then I will. Okay, 110 times 30 times 0.045. This one is 2 hours, so 120 minutes. Okay, everyone get the same answer? I can hit calculator's buttons incorrectly also.
I need to.
If you did more steps and rounded more times, I could do that. Questions on either of those two that we've done? Okay, let's keep going. So she weighs twice as much as her daughter. If they both do the same exercise, does she always burn twice as many calories?
Yes.
Yeah. The little answer says, in theory, yes, right? Realistically, if you've ever gone for a walk with your kid, you know that they're doing who knows what. But in theory, yes. If they were doing exactly the same exercise, she would always burn twice as much. Okay. Oh, come on. There we go. Okay. If you're trying to lose weight, then you want to burn fat calories. The problem with that is that when you're exercising a lot, you need short-term energy, which your body metabolizes carbs to do. So there's this oddness that the harder you're exercising, the smaller of those calories, percentage-wise, will be fat calories. On the other hand, if you're exercising harder, you're just burning more calories. And that actually turns out to be more important. So when walking, about 3/4 of the calories burned are fat calories, and only 1/4 are carb calories. But when you're running, it turns into about half and half. You need more carbs to keep going at that pace. So 2 people, they both weigh 150 pounds. They both exercise for 30 minutes. One person walks, one person runs. How many fat and carb calories do they each burn. So I'm not going to have us do this right now, but look at that before I see you on Tuesday. You'll have two problems like we just did, the walker and the runner. And then one of them you'll have to go 3/4, 1/4. And for the other you'll just split it up half and half and see how they compare.
This exact one on this page?
Yeah, do just this exact one.
Okay. What page is this again?
Health decisions. Okay, and you can check your work because it's right now. 14. Okay. Can we check the exercise formula? Not really in class. We don't have some device here that would measure how many calories we burn. But we can estimate. The more you exercise, the more you need oxygen. And for aerobic exercises, it's fairly linear, fairly proportional. If you're exercising twice as hard, your body needs twice as much oxygen. So our breathing will increase, our heart rate will increase, and maybe we can see how that works. So we'll go back to patterns, sort of like we did before. You want some sort of exercise where you can double and triple the intensity. So one group of students last term said, well, when I'm resting, every 20 seconds I have a breathing and a heart rate like that. Then they thought they are going to run the same pace, but just for longer. So they sort of went around the hallways, and then for 20 seconds measured their breathing and heart rate. And there was no pattern here, but the breathing actually made a pattern. Another group of students decided that they would always go the same distance. They would just go faster and faster. So they went from one end of the hallway to the other. When they were resting, that would be like 0 baseline. Then they walked the entire hallway. They timed it. Then they tried to jog that twice as fast as the walking. And then run it 3 times as fast as the walking. And they managed to get a pattern for both. So that was pretty remarkable. Then there was another group that did jumping jacks. They didn't want to go out in the hallway where everyone would see them. So they started at rest. They did some ridiculously slow jumping jacks, because if you're going to get 3 times as fast, you have to start really slow. And then they did twice as fast as that, and then they did 3 times as fast as that. So trying to get so many in, I think it was like 30 seconds or something, they did jumping jacks for them. Anyway, and as they went faster and faster, they had a heart rate pattern, but not a breathing pattern. Who knows why? Bodies are complicated. Anyway, so those kinds of patterns can happen.
Are we doing this?
Yes. So now it's your turn to do this. I'm going to leave one of these up to sort of help you organize yourself. You'll want something on paper that looks sort of like this. You can do it by yourself. You can do it with a group. Find out who is the token person to be your exerciser if you're in a group. It's hard to do by yourself because it's hard to measure your own breathing and heart rate at the same time. It's easier to have whoever is in your group be your exerciser, that they come back and they sit down here, and then they're going to count their own breaths while someone else takes the breaths or something like that. So we have 17 minutes of class. Let's do this for about 10 and then wrap up at the end. See it. Okay, we're back. We wrote a little bit for 2 other groups. We're recording the 3rd group now. Okay, breathing rate?
4, 9, 9, 11.
Okay, and heart rate?
23, 30, 36, 39.
trend, but not a good pattern, really. Okay. Do you have numbers for us, too?
They
Oh, I was actually with.
Oh, you were with them. Okay, so we're done. We just have an extra one. Okay, so this is actually completely normal. The fact that the website has only examples that made patterns was because I didn't put up the ones that didn't. So for various reasons, either because you kind of warm up and get used to it, it's normal that the increase slows down as you get further along. And it's also normal to pick something like push-ups that aren't really twice as hard when you do them. So, but this was done just, it's a good use of 10 minutes. You get to see that this kind of experiment isn't easy, that actually measuring people's metabolism and so on is more than we can do in class, but it's not beyond what we could understand. We just don't have the right tools and things like that. So, there we go. Okay, move that back up here. Before I go on to another topic, do we have any questions about the patterns subtopic that we did on Tuesday? Yes.
I know the answer, but I just want to be clear. There was no formula to the patterns. That was all just recognizing time, right?
You were making a formula each time.
Okay,
Each
so
problem had its own formula.
we weren't supposed to know something in advance.
No. Okay, well, if we are now getting together and no one has more questions about the subtopic, that means that its time is up. So a week from today will be when your patterns is done. A lot of you will just get it done over the weekend because that's easier than me. Okay, but we have a couple more minutes. Let me give you a preview of what's happening as well as wrapping up what we just did. And then I'll let you go on time. So we talked about calories and exercise. Next we're going to move on to food. You will need to bring a piece of food to class on Tuesday. So make a note. I'll remind you in the email, but we're going to do that. We're going to talk about different kinds of calories, carbs, proteins, and fats. And we're going to talk about how many calories a day the USDA people want you to eat. And again, some of this we'll talk about how realistic it is and things like that, as well as the...
Do we need to have a nutrition facts on our food?
No,
Okay.
no, just a piece of produce, right? Some sort of fruit or vegetable. I'll tell you why in a moment. We're going to do some review. Well, we were setting up class. Someone was talking about what I call RipLop, right into percent, left out of percent, scooting decimal to go in and out of percent. So all the stuff that you, in theory, you're supposed to know on Math 20, we'll review it when we need it. I'll start doing that. And then we're going to move on to metabolism and have some formulas. We might not get to your vegetable, so if we don't, that's fine. But if we are really speedy, then there's what's called the yield percent. If you buy a potato and it weighs exactly a pound at the store, you don't get a pound of potato in your pot because you have to trim it and stuff. So how much goes away in between the shopping and the pot? And we want to actually do that a little bit in real life. So this might be actually Thursday when I take out the knives and the electronic scale and we weigh things and trim them and weigh them again. But have it Tuesday just in case it's what we decide to do. And I will bring some extra. If you forget or if you get hungry and eat your apple at lunchtime because our class is at noon, then there will be something for you to trim. But it's more fun if we have variety. Okay, so that's sort of a preview of where we're going. We'll learn more about calories, more about metabolism, and actually get on to playing with food. So have a good weekend.